I'm Mr. Malden, and this is the Math Toolbox. Today we are going over expressions, all right? Learning how to identify different parts of an expression, and then also going to be able to get into evaluating expressions whenever we're given the value of them. So we're just going to go ahead and hop right into this and start with just some terms, all right, or vocab terms. Talk about what algebraic expressions are, variables, and things like that. So, definitions. All right, algebraic expression. All right, this right here, this expression that you see right here, is an algebraic expression. All right, and the reason why we call it an algebraic expression is because it has variables present. All right, so you can make expressions, mathematical expressions, all different kinds of ways. All right, you could just have something like this: 3 plus 4. All right, that's an expression right there. All right. You can just have just a number, all right? 3 plus 4 equals 7. This is also an expression right here. These expressions right here are referred to as numeric expressions because all we have are numbers and operations, all right? Whenever we add a variable to it, which we're about to see the definition of a variable in a second, but essentially it's a letter that represents an unknown number. Whenever we see these variables, it all of a sudden becomes algebraic. That's what makes an expression algebraic, is the presence of variables. So algebra is just math with variables, all right? So an algebraic expression by definition is a combination of variables and constants mixed with various operations, and it does not contain an equal sign. All right, you should have learned that already. If you haven't learned that already, then just know this, that expressions don't have equal signs. They become equations when you were to put, an expression on the other side of an equal sign. So this would be an equation, all right, because I see an equal sign and I see an expression on either side of the equal sign, right? Minus or taking away the equal sign makes this just an expression, all right? And the terms of the words that we use when we're trying to find the answer are like in this kind of sense like here, we use simplify. All right, we're going to simplify expressions and we solve equations. All right, so if I had put an equal sign here and an expression on the other side like this, now I have an equation. Equations we solve, expressions we simplify. All right, so whenever you see the term simplify the expression, all it's asking for is the answer. All right, just kind of condense it down to make it as simple of an answer as possible. All right, when you have variables, we're going to learn this later next week, but you can only simplify them to a certain extent. But forget all about that for just a second, and let's just worry about what expressions are. They're mathematical statements without equal signs, and they're algebraic whenever they have variables. All right, now let's look at this expression right here, and let's just identify the different parts of the expression. All right, first you've got the variables. All right, the variables are any of the letters. All right, any of the alphabetic letters or other symbols as well. All right. That are used to represent an unknown number. So they're kind of a place saver, all right? So this term right here says 3x. It's saying 3 times x. We don't know what x is. It could be any infinite number of numbers, all right? It could be negative 100. It could be 2 million. It could be 0.1. It could be 2/5. It could be any number, all right? So we don't know what x is, and so we represent it with a variable. We don't know what that number is, so we represent it with a variable. X is just a place saver, all right? So variables are the letters that are place savers for unknown numbers. The numbers that are attached to the variables, signifying that we're going to multiply that variable by that number, all right, are called coefficients. So that's a special math word. Coefficients are just referring to the numbers that are attached to variables, signifying that we're multiplying that variable by that number, all right? Numbers all by themselves, which until middle school is all that you've ever dealt with in elementary school, they're all called constants, all right? You just call them numbers before, but they have a special name. They're called constants, and constants are numbers that are not attached to variables. So inside of an expression, you're going to see some numbers that just stand alone and some numbers that are attached to variables, all right? The ones who stand alone, they're called constants, all right? And then finally, the terms. The terms of an expression are variables or constants in a mathematical expression that are separated by a plus or minus sign. So in this case right here, you see this minus sign and this plus sign. You can kind of see them as separating points. In front of that minus sign, you see a 3x. That's one of the terms, right? Then after the minus sign, you see this 2y, but you need to realize and understand from, this point and from now on and forevermore is what I tell my students, that minus sign influences that next number to be something that it's not, or that it's opposite, all right? So that minus sign influences that 2y to be a negative 2y, all right? So that's the next term, and then the final term separated by this plus sign is that 5 right there, all right? So the terms in this expression are 3x, negative 2y, and 5, all right? So by definition, they're the variables that also include the coefficients attached to them and in the constants, all separated by the plus and minus signs. So just a word of caution, you've heard me say this before, and I'll continue to say this. You'll save yourself a lot of headache if you will always rewrite the expressions using only addition, all right? And what I mean by that is you're changing that expression to using keep, change, opposite to only having addition. So you're getting rid of any of the subtractions. So I just wrote that expression out on my board. It just looks like this. Whenever I see an expression right here with different variables and coefficients and constants and operations and things like that, we see that our terms are all separated out by the plus and minus signs. Those are our terms right there. But we need to be careful, all right, to apply keep, change, opposite at the very beginning to any of the subtractions. So if you look at that subtraction right there, we're going to keep the number in front. We're going to change that to addition and change the next number to its opposite, all right? So the next number, instead of positive 11, it was negative 11. And so on for this one right here, we're going to keep the one in front, change that subtraction to addition, and then make 5 its opposite, which is negative 5. And now you can see, the different terms right here. That subtraction influences that 11y to be a negative, and that subtraction influences that 5 to be a negative as well. So you always want to rewrite your expressions using only addition. And I have it typed there. You can kind of see it, but I just did that one by hand. So this expression is the same exact one as this one up here. I just applied keep, change, opposites to the subtraction to make it an addition problem. Now be careful when you do that. Don't just change the subtraction to addition. You have to make sure that you apply keep, change, opposite. If you're going to change the subtraction to addition, the next number has to be opposite. All right. So let's try this one, all right? You've got 3 questions down there about this algebraic expression right here that we already worked with. We already turned it to an addition problem by applying keep, change, opposite to all the subtractions. There's 3 different questions about it. What are the terms? What are the coefficients? And what are the constants? So what I want you to do right now is pause the video and see if you can just, take a chance. See if you can come up with the correct answer for those 3 questions, and then you can come back and get the answer, all right? So I'm going to go ahead and go forward with the answer, so make sure that you go ahead and pause, try it yourself, and then come back for it. All right, the terms in this algebraic expression are all the variables and constants that are separated by the plus or minus signs. Well, we already turned the minus signs, all right, the subtractions, to addition by applying keep, change, opposite. So you just see 3 addition, symbols there, right? So you are going to look at the numbers that are separated by those plus signs, all right? So you've got 16x, you've got negative 11y, you have negative 5, and you have 4z, right? Hopefully you're seeing that this is not very difficult at all. So the terms are just the variables with their coefficients attached to them or constants that are separated by addition signs. All right. The coefficients in this expression are going to be the numbers that are attached to the variables. All right. So in this case, we've got 16, we've got negative 11, and then we've got 4, positive 4 right there. All right. The one number that we left out is that negative 5. It is not attached to a variable, so therefore it is a constant. All right. So that's the answers to the questions here for identifying the parts of this particular expression right here. All right, let's go to the next one. See if you can do this one all by yourself. All right, you can go ahead and pause the video. Before you pause, just a word of caution. Make sure you apply keep change opposite to any subtractions. That might help you out a little bit. All right, go ahead and pause the video and see if you can identify the parts of this expression. All right, what are the terms, what are the coefficients, and what are the constants? All right, the terms in this one, all right, if we apply keep change opposite, we'll see that this one, that would be a plus sign, so that 5 would be a negative 5b, and then this 9 would be a negative 9, all right, because we changed it to its opposite. So the terms in this expression are 4a, negative 5b, negative 9, positive 11b, positive 3a, and positive 21, all right? The spiel that I give my kids in class is that sometimes in life we are around negative people. There's negative people around us all the time, all right? And if we spend too much time with the negative person, sometimes they influence us to be something that we're not, all right? The same is true in math, all right? With the subtractions, you can kind of consider that a negative person, if you will. It's going to influence the next number to be something that it's not. So that 5b right there, it looks like a positive 5b, but that subtraction is influencing it to be its opposite, all right? It's negative, all right? Now then, what are the coefficients? The coefficients are going to be the numbers that are attached to the variable. So in this case, we have 4, we have negative 5, we have 11, and we have 3. Those are the coefficients, the numbers that are attached to the variable, signifying that we are multiplying that variable by that number, right? And then finally, the constants in this expression are negative 9 and 21. They're constants because there's no variables attached to them, all right? Well, we are halfway through the lesson. That's great, all right? So we've learned the different parts of expressions and being able to identify the parts, the terms, the coefficients, the constants of expressions. Now I want to talk about evaluating expressions, all right? Before we start getting into really simplifying and working with expressions in detail, I want to kind of ease into this by evaluating expressions. So you see that word evaluate. That's different than what you a lot of times see. A lot of times you see the word simplify. Whenever you see the word simplify, they're just asking you to take that expression and write it in the simplest terms possible. All right? Evaluate is different. All right? Evaluate means they're going to give you the value of one or all of the variables inside the expression. In this case, we just have one variable in the expression. We have 4y plus 30. That's our expression. And we're told to evaluate that expression when y equals 5. All right? The way that you're going to evaluate is you're going to use a substitution property to take that value of y and substitute it for y inside the expression and then simplify it on out. So it would look like this, all right? I've got that 4 right here. I'm just going to rewrite the expression, except when I see that variable, I'm going to write a parentheses, just like that. Finish out writing the rest of the expression. And inside that parentheses, right, because this is a y, all right, we're told that y equals 5. Inside that parentheses, I'm going to put the 5 that y was a place saver for. All right. So again, not all the time. You don't always, it's actually probably pretty rare that they tell you exactly what the variable is. A lot of times you're just working with expressions and equations and solving or simplifying expressions like this. But sometimes they say evaluate an expression. When they do, they mean they're going to give you the value of one of the variables, and you're just going to have to substitute that value in for the variable in the expression, and then do the math, solve it on out. PEMDAS tells me I've got to do multiplication before I do that addition, so I've got 4 times 5 is 20. I'm going to bring down that 30, and then 20 plus 30 is 50. So I substituted 5 in for y, and then I just did the math that it told me to do, right, by order of operations. All right, order of operations, we use PEMDAS for that. You have to start with parentheses first. Inside that parentheses, you can't do anything. You can't simplify that anymore, so we're done with that. There's no exponents. That's why we, multiplication division is the next step, so we've got to do that before we do that addition, and that's why we did that 4 times 5 equals 20, and then you can finish up by adding the two constants together to come up with your final answer. All right, so that's how you evaluate an expression. Now I want you to try this one right here. You try this one. This one actually has 2 variables. All right, so on your scratch sheet of paper, start out by writing the expression 2j minus 3k plus 5, all right? And then you're going to want to take it on down to the next step, all right? We know that j equals 7 and k equals 4, all right? So you're going to want to take that on down to the next step where you substitute, all right? We're going to substitute because we're evaluating this expression. We're going to substitute 7 anywhere we see a j, and we're going to substitute 4 anywhere we see a k. And we're going to put it inside those parentheses so that we don't lose sight of the fact that this is multiplication here. There's there's an invisible operation right here in between the 2 and the j, and that invisible operation is multiplication, all right? So that's why I tell you whenever you rewrite your expression, you want to put parentheses for the variables just like that, and then you can take the number and put it on the inside of the parentheses that the variable is equal to. All right. So then we've got 2 times 7. We have 3. I'm going to put a parentheses here for k, and I'm going to substitute the number 4 in for that, and then I've got my plus 5. I'm going to go ahead and just solve it on down. Again, PEMDAS tells us we're going to go to parentheses first. All right. There's nothing we can do inside the parentheses. There's no exponents. Now we're down to multiplication or division. So I see 2 different multiplication operations right here. I've got 2 times 7, that's 14, all right? And then I've got 3 times 4, that's 12. I have to do that multiplication before I can address that subtraction right there. And then we have plus 5, all right? Now, I told you before, it's a really great idea to always turn those subtractions to addition, all right? Whenever you're solving expressions, you can do that by applying keep, change, opposite, all right? So now we have 14 plus negative 12 plus 5. I'm going to finish this up by putting this on a tug line, all right? That's one of the tools that I love to use and I love to teach. We're going to put 14 on team positive, 5 on team positive, 12 on team negative. We'll have 19 positives, 12 negatives. Is there a war? Yes, there is. So we're going to subtract 19 minus 12 is 7. And who won the war? The positive did, so that's a positive 7. So our final answer is positive 7. If you don't understand the tug line, what I just did, you're welcome to go back to the video that I have as adding and subtracting integers. I talk about it, and I talk about keep, change, opposite as well. Both great tools to learn for when you're adding and subtracting positive and negative numbers, right? So final answer for that one was positive 7. Let's do one more, and we'll be done. All right, once you go ahead and try this one, go ahead and start out by writing that expression, all right? And then substitute the value of the p. The value of p is 7. Substitute 7 wherever you see p, and then solve it on out. You can go ahead and press pause on this video if you'd like to try it yourself, and then you can come back and you can see, compare it to my work, all right? So we've got 3 times 2p plus 6, and we know that p equals 7. All right, so again, what we're going to do is we're going to carry this on down. We're going to rewrite this. Now, I know I'm going to substitute p. I'm going to put a parentheses, like parentheses around and substituting it for p. So since I don't want to have parentheses stacked next to other parentheses, I'm going to go ahead and substitute brackets for the parentheses here, for the inside, for the outside right there. So I can make a distinguish between You're not going to distinguish between the different groupings, all right? I'm having a hard time talking today, I guess. All right, then we're going to rewrite this. We got 2, and instead of the P, I'm going to write a parentheses right here, and then I've got a plus 6. And I'm going to take the value of P, which is 7, and put it right inside the parentheses because that P was a placesaver for that 7. So now you can see why I wanted to put the brackets here, all right? If I hadn't put the brackets, it would look something like this, all right? Which can look a little confusing because you have a parentheses next to another parentheses. So that's why we like to use these different kinds of groupings. There's all different kinds of groupings in math, all right? You've got parentheses, you've got brackets, you have braces like this, you can have absolute value bars, all right? Those are all different kinds of groupings. Well, these right here, these first 3, the parentheses, brackets, and braces, they don't have any special function necessarily. This is kind of the default grouping that we usually use as parentheses, but when you have a grouping inside of a grouping, we like to not represent that using the same, I don't know what that is, the same grouping. You want to use separate groupings to indicate to distinguish between the fact that you've got 2 different groupings like this. So you've got a grouping inside of another grouping, so we use the brackets on the outside like that, so it's not too confusing. All right, now we're going to simplify this on down. All right, 2 times 7, again, PEMDAS tells us we need to go to our groupings first. A lot of people call this GEMDAS, all right, because we're talking about groupings first. So we're going to go to our big grouping. And on the inside of that grouping, there's a lot of simplification that we need to do before we address this multiply by 3. So inside there, we've got 2 times 7, that's 14, right? I did that work. I'm going to bring down my 6 that I haven't touched. Go ahead and close the brackets around it and pull down that times 3. I haven't touched that yet, so I'm going to pull that down so I don't forget that I have that. All right, then inside the grouping, I've got 14 plus 6. That's going to be 20. All right, and I'm going to pull down. Scratch out what I didn't do, bring down everything that I didn't touch. All right, so I'm going to bring down that times 3. And now my grouping is simplified. I have no exponents. All right, so now I'm all the way down to multiplication and division. Multiplication and division. I've got 3 times 20, that's going to be 60, and I have no addition or subtraction, so that's my final answer right there. So I evaluated that expression when P equals 7, and you can see all the work right there that led me to my answer of 60. All right. I want to encourage you, if you haven't done so already, hit the subscribe button down below. Click the like button if you like this video, if it helped you at all. Click that like button. That's going to tell the algorithm for YouTube that this is a video that's valuable for other students as well. If you're a student in middle school, whether 6th grade or 7th grade, all these concepts, even 8th grade, will help you. And so I want to encourage you to stick with me throughout the year. I'm going to continue to upload videos, and I hope you'll have a great day. Okay, bye-bye.